Okay, for this first part, looking into homogeneous second order differential equations, I'm going to give you a little bit of a foundation here and just kind of add in a few details, and we'll be looking at this through two separate parts, and the second of which will be sort of going directly toward what you have in dealing with homogeneous second order differential equations in your textbook, but just sort of adding some mortar to the bricks. Let's say that, okay, for what we have in this equation, now we got ay double prime plus by prime plus cy is equal to 0, and in this particular case we will have y as the dependent variable, and we'll say that for the independent variable we'll just have this to be the traditional letter x, and just sort of taking what we have here. Okay, so we got ay double prime plus by prime plus cy is equal to 0, and okay, so just rewriting what I have here in terms of Leibniz's notation. Okay, so we have a d squared y over dx squared we have plus b dy over dx plus c times y is equal to 0. Now for what we will be ultimately looking into is rewriting what we have in terms of algebraic equations. Like a second order differential equation we will write as a second order algebraic equation, or a quadratic equation that can have up to 2 characteristic roots. And now let's say that rewriting in terms of substitution variables or other variables that are functions of x. Okay, let's say that if we have on the one end, okay, let's say if I let y be equal to u, and what I would have here, okay, if I let y be equal to u, I'm going to have a d squared u over dx squared plus b du over dx plus cu be equal to 0. And let's say that if I also let y be equal to v, so again just putting v in place of y, so our homogeneous second order differential equation will become a d squared v over dx squared plus b times dv over dx plus cv is equal to 0. And now if you notice, okay, just sort of amalgamating together what we have here. Okay, so if you notice, okay, we have so if I have like d over dx of the sum of u and v, okay, so this would be du over dx plus dv over dx, and also in terms of second order, so if I have d squared over dx squared of the sum of u and v so this will become d squared u over dx squared plus d squared v over dx squared. Okay, and if you notice, okay, so and I was going to kind of mention here, okay, so we got this, and of course a little bit reflexive. We got u plus v equal to itself. Right. And so just looking at consolidating, okay, so it's going back to our original equation. Okay, so you have a d squared y over dx squared plus b dy over dx plus c times y is equal to 0. Well, if you notice, okay, I can write that we have a d squared of the sum of u and v over dx squared and a half plus b and a half times d over dx of the sum of u and v and a half plus c times the quantity of u plus v is equal to 0. And this is going to be our original equation. Okay, once we have replaced y with the sum of u and v. Okay, so and for what we have in this particular case, all right, so if we have that y is equal to u and that y is equal to v are solutions of the original equation. So individually, if we have y equal to u and y equal to v to be solutions of this equation, well, guess what? So also, are we going to have as another solution y equal to u plus v?